Today we will discuss about thin cylinders and spheres. So when we call a cylinder as thin cylinder or thin sphere, when the thickness of the wall T is about 1/15 to 1/20 of its internal diameter. So wall thickness should be 1/15 to 1/20 of its internal diameter. So T should be 1/15 to 1/20 of D, if D is the internal diameter. Then we call it a thin cylinder or thin sphere. Okay, so normally these thin cylinders or thin spheres are used as pressure vessels. Some type of liquid or fluid is held inside it, and there is some internal pressure of the fluid, and that cylinder is resisting, the cylinder material is resisting the fluid pressure. Okay, so if we consider a cylinder, and if there is object inside it, so there are two ways the cylinder may be failed. One is like this, this way, okay. In this way the cylinder fails for circumferential stress or hoop stress. So if the cylinder get separated in this way, then the stress which is inside the cylinder material is called hoop stress or circumferential stress. Or hoop stress. Okay, and how can you find the value? If the internal dia is D and the length of the cylinder is L, then this middle area is D into L, and if the internal fluid pressure is D, internal fluid pressure is P. Now P into this area, this is the force which are trying to separate these two halves in these ways, and the material here is providing the resistance. So the force which is the cylinder resisting is equal to the resistance force of the cylinder wall. So the cylinder having circumferential stress generated on it, if sigma C, then sigma C working on these two edges, this edge plus this edge, so that will be, this is T, thickness of the cylinder, into L, into, we have two sides, one here, another one here, that's why we are multiplying with 2. So if we look at it, then L and L get crossed out, so sigma C becomes Pt by 2T. So this is the expression of circumferential stress or hoop stress generated on the cylinder material. Now there is another way the cylinder may be separated. The because longitudinally in this case the forces are acting like this, and the force at the middle of the section is the internal pressure into this area, which is pi d square by 4, and that force which is exerted by the fluid is supported by the material in this region. So if the internal dia is small d and thickness is t, then and the stress generated is sigma L, longitudinal stress, then sigma L into this area is pi d into t. So from here we get sigma L is equal to P, this is also small d, this is also small d, so P into d, pi gets cancelled out by 4 into 1d gets cancelled out, so Pd by 40. This is the expression of the longitudinal stress. This is called longitudinal stress. Okay, so in a material these two types of stress are working in a thin cylinder. Now if this cylinder has been made by joining two materials, same material of two parts joining like this, here there will be one joining, here there will be another joining, here one, here another. So in such case, if the joint efficiency is eta L, which is joining efficiency, when the joint is longitudinal, then the efficiency is eta L. So in such case, sigma C will be Pd by 2T into sigma L. Okay, when there is a joint, longitudinal joint, and when there is a joint like this, then this joint is circumferential joint, and the efficiency of circumferential joint will be this eta C. So joining efficiency. So in such case, the joint efficiencies will express in this way, and this will be the permissible or the generated longitudinal stress. The equations changes in this way. Now these two equations are going to be required while we are going to solve the problems. So these four equations will be required. When it is without joint, this equation; when with joint, then this equation, this and this. Okay, and in case of cylinders, this is cylinder. When in case of sphere or spherical pressure vessel, then because of the symmetry in all directions, the stress is same, the internal pressure of the fluid is same, and the force will be exerted like this way. So the force exerted in one direction is how much? If the stress is sigma, the area will be pi d square by 4, and that will be supported by this material over here. So that will be, this is P, because this is internal pressure of the fluid. This is P. This P is working here. Okay, so the force exerted by the internal pressure of the fluid is P into pi d square by 4. That is supported by the material on the wall like this. So if the stress generated is sigma in case of sphere, then sigma into this is pi d into t, or from here the stress generated on the sphere wall will be pi into d by 4 into t, so which is lesser or similar as when we are talking about longitudinal stress or circumferential joint. It seems similar, but in case of longitudinal joints, the circumferential stress generated and this value is maximum. So when we design for these thin cylinders or thin pressure vessels or thin sphere, then for designing purpose we always use this formula. So this is used for all the designing purposes. With factor of safety. So we have to also use the factor of safety, and this formula should be used for designing purpose. Okay, so you have to solve problems. You have to solve lot of problems. Okay, let us start with a very easy problem. So one more thing, for a particular portion of material, so then there are two type of forces applicable, which is sigma c and another side sigma l, and if there is any twisting or couple is working, then it should look like this, and in such case the stress to be found out, it will be principal stress if required to be found out, and that principal stress can be found out from the theory we have learned in principal stress chapter. Okay, so if you need to find out the stress at any plane, any particular plane, then also you can find out if you know this values. Here you need to know the shear stresses, which can be found out from the value of couple or torque, whatever is applied. Okay, now we will solve the problem, very simple ones. A boiler is subjected to an internal steam pressure, boiler pressure. Boiler internal pressure P is 2 Newton per millimeter square. The thickness of the boiler plate is 2 centimeter, which is basically 20 mm. Okay, permissible tensile stress or the sigma max is 120 Newton per mm square. Our job is find out the maximum dia when the efficiency of longitudinal joint is 90% and circumferential efficiency is for circumferential joint is 40%. So we have to find out the internal dia. So boiler and it is mentioned that circumferential joint and longitudinal joint, so it should be a cylindrical one. Okay, now from the equation we know sigma 1 is equal to PD by 2 into sigma L into T. So here if we put the values, sigma max is 120 Newton per millimeter square and P is given 2 into D is not given, we keep it as D by 2 into eta L is 90%. That means we have to put 0.9 into thickness will be as 20. Now what we will get as the value of D is 2160 millimeter from the formula. Now again, if we use the equation sigma c is equal to P into D by 4 into beta c into T, in such case this is also to be used as 120, as the value max value is 120. So in such case, if we put the values, P is equal to 2 D by 4 into 0.4 into T value is 20, then if we find out D, it becomes 120 cm. Now we know when we solve the problems, we have to design for taking the value of maximum stress generated. So we know this circumferential stress generated always more, so that's why we need to assign the maximum value 120 to sigma c, and then we will get the minimum D. So if we take minimum D 192 centimeter, then our design will be correct. So if we take 192 cm, okay, if we take this value to 216 centimeter, then the problem is if we put it this D value to find out the corresponding sigma c, then we will get 2 into 216 by 4 into 0.4 into 2, which will be 135 Newton per mm square. So in such case, if take D equal to 216 centimeter, then the circumferential stress generated will be 135 Newton per mm square, but the maximum value is 120 Newton per millimeter square. So this design will of course fail. So that's why we need to assign the maximum value at sigma c, which is circumferential stress, to be taken the most highest value. So 120, the maximum value assigned as circumferential stress, and in such case D is found out 192, which is feasible. So that's why the maximum internal dia can be taken as 192 centimeter. So this is how we need to solve the problems. You need more problems to solve, but the formulas required are only these 5 formulas. This is one which is for sphere, and for cylinder 1, 2 and 3 and 4, these formulas are required. Okay.